Dear friends, in this video lesson, I'm going to discuss part 4 in the topic A Journey in Linear Programming, and part 4 deals with modeling and solution. So I'm going to show you how it could be easily modeled in the spreadsheet environment, and then using the solver engine, how do we obtain the solution? The very same example, for the sake of recapitulation, is shown here. Maximize Z is equal to 15x1 plus 21x2 subject to x1 less than or equal to 4, 2x1 plus 3x2 less than or equal to 18, x1 plus x2 less than or equal to 8, and x1, x2 greater than or equal to 0, non-negativity. The coefficients in the objective function, maximize is Z, 15 and 21, they represent the profit per unit in dollar terms. The first constraint is the sales constraint, x1 less than or equal to 4. I cannot sell more than 4 units. The second constraint is 2x1 plus 3x2 less than or equal to 18 is the constraint on the availability of raw material 1. Availability is measured in kilograms. The third constraint is x1 plus x2 less than or equal to 8. This represents raw material 2 constraint. 8 kg only is available, and we superimpose x1, x2 greater than or equal to 0, the non-negativity constraint in the linear programming. So how do you first model it? So I will take you in a step-by-step manner. I just write here decision variables and put here x1 and x2. Then I put a yellow color here that these decision variables, the values are unknown. We'll have to find out by solving the problem. So I enter some trial solution, just 1 and 1. These are trial values, and they are shown in cell B4 and C4. And they will have to be varied to get the final solution. Then I write here profit per unit, the coefficients first, 15 and 21. So 15x1 plus 21x2. $15 is the profit per unit of product 1, and $21 is the profit per unit of product 2. Now, how do you state the objective function? I write here is equal to a formula now. 15, this cell is B5 star this cell B4 plus C5 star C4. So I get a value here 36, which is 15x1 plus 21x2 for the trial values 1 and 1 for x1 and x2. If you double click, you have the formula. Then I write here constraint 1 coefficients first, 2 and 3. So what is the formula here? 2x1 plus 3x2. Sorry, this is the first constraint is sales constraint. So I write here 1. Because the coefficient of x1 is 1, I write here 1. And I put here a formula is equal to 1, this cell B7 star B4, sorry. the value will be naturally 1. If you double click, you get the formula which we have copied. Now, constraint 2 is the raw material 1 constraint, which has coefficients 2 and 3. So 2x1 plus 3x2 I put here is equal to this cell, which is B8 star, this cell which is B4 plus C8 star C4. So if I double click here, you get the formula B8 B4 plus C8 C4. Then the third constraint, which is raw material 2, constraint has coefficients 1 and 1 in the canonical form. Therefore, its value is equal to this cell B9 star B4 plus C9 star C4. So initial value is 1, 1. Therefore, this will be 2. I double click B9 times B4 plus C9 times C4. These are the constraint of the left-hand side, constraint values to the left-hand side. Now, the right-hand side, I put here 4 for the sales constraint, 18 for the raw material 1 constraint, and 8 for the raw material 2 constraint. Now, I have modeled the problem I need to solve. If you wish to look at what you have modeled, you can see this here. So, let me just show you that here. This is what you have modeled here now. You can see that. The formula is clear here. B5 into B4 plus C5 into C4, B7 into B4, B8 B4 plus C8 C4, B9 B4 plus C9 C4. These are the values of the right-hand side of the constraint. Constraint 1, 2, 3. This is the objective function. Let me go back to the original mode where I have the values displayed. And therefore, now what I'm going to do, I'm going to invoke solver, data solver. So I have to state this is the objective function cell, the green color one. And I say maximize this. I have stated that. How do you maximize? By changing the decision variable cells, these yellow colored ones, B4 and C4. Are there constraints? Yes, of course. And in Excel spreadsheet model of the solver, when the constraints are all of the type less than or equal to 4, it's less than or equal to type. First one is 4, second is 18, third is 8. I simply put the constraint of the left-hand side and then the values of the constraint, which is on the right-hand side. Put here. Now click OK. So the model is formulated. I need to state it is simplex LP. Linear programming using simplex method. Non-negativity constraint is anyway by default is there. Make constraints variables non-negative. And now I am ready to solve. So let us see what the computer gives. Solve. It says solver found a solution and all constraints are satisfied. Now we have solved the problem. For the sake of future discussion, if any, I put here answer and sensitivity analysis part and click OK. So that I have the answer report. If I click, I get this. These are the answers given. Then I have here the sensitivity part report, which gives you some useful information to interpretation of the problem for the decision-making situation. So, therefore, what I say here is, we have got the solution, and let me just say here, sheet 1, I go back to the sheet 1, and we have solved the problem. This is the solution. X1 equal to 4, X2 is equal to 3 1/3, 3.33. Maximum profit is $130. This is what you have got precisely in the graphical mode. In the next part, let us interpret the sensitivity analysis for decision making, which will be part 5. Thank you very much. We will see you soon in the next video.